Hi everybody, it's Mrs. Dunn. Today we're talking about Bayes' formula. So what I'm going to do in this screencast is first I'm going to introduce you to Bayes' formula. Then we're going to go through two examples, one with a Venn diagram and one with a tree diagram. Let's get started. All right, this next screen, I hope you're sitting down. It looks a little confusing, but here is Bayes' formula. All right, let's break this down so that this makes sense to you and you can understand this formula. So first of all, we have these events. Consider them U1, U2, all the way up to UN. They're mutually exclusive, which means they can't happen at the same time. And the union of these events makes up the sample space. That's the entire sample space. Let's call it S. Then we have some arbitrary event S. Arbitrary event E that happens in the sample space, and the probability of that event can't be zero, that event E. All right, just look at this for a minute. Right here, the probability of U1 given E. Doesn't that look familiar? We did this in this previous screencast I made about conditional probability. The probability of U1 given E is the probability of U1 and E divided by the probability of E. Okay, probability of U1 and E, that's not new. This probability of E, though, is a little bit more complicated. See, the probability of E is the probability of U1 and E happening, U2 and E happening, and U3 and E happening, all the way up to UN and E. I think this is going to become more apparent in the next screen. So we're being asked to find, using this Venn diagram, the probability of U1 given R and the probability of U2 given R complement. Okay? So look at our rectangle, look at our Venn diagram. U1, U2, and U3 are mutually exclusive, and those rectangles make up our sample space. Let's look at this U1 given R to begin with. Remember that formula. The probability of U1 given R is the probability of U1 and R divided by the probability of R. Okay, what's the probability of U1 and R? Think about that for a minute. Here's where U1 happens. We're in the U1 rectangle, and R is happening. So that's this number 5. The total of these numbers, when I add these all together, 5 plus 10 plus 15 plus 20 plus 20 plus 30 gets up to 100. So 5 out of 100 is the numerator of this fraction. Okay, what's the probability of R? Well, that's U1 and R, U2 and R, and U3 and R. So we're going to add 5, 15, and 20. I have this written on the next screen. Now remember, it's 0.05 because it's 5 out of 100. 0.05 plus 0.15 plus 0.20. 0.05 divided by 0.40 is 0.125. Okay, let's see if you can do the next one. Find the probability of U2 given R complement. Pause the video right now and see if you can get the answer. All right, so first of all, the probability of U2 given R complement, the formula is here. The probability of U2 and R complement divided by the probability of R complement. Did you get 0.33? Okay, the probability of U2 in R complement, U2 and not in R, is 20 out of 100. And the probability of U1 and not in R, U2 and not in R, U3 and not in R is going to be in the denominator. So that total is 0.20 over 0.60, which is 0.33. How did you do? Okay, let's look at this whole concept with a different chart. Now we're going to use a tree diagram. So use the tree diagram to find the probability of C given V and the probability of V given C. I use this example because I want you to see that you're not going to get the same answers. The order these letters are written makes a difference. Now, that probability of C given V, the first one, The probability of C given V is actually in the tree diagram itself. It's 0.20. So the probability that C happens given V happened. So V already happened. The probability that then C happens is 0.2. Okay, when I change the order, that's going to change the problem. So if I want the probability of V given C, the equation for that is the probability of V and C divided by the probability of C. So the probability of V and C, remember, is this 0.6 times 0.2. Now, what about that denominator, the probability of C? Well, we don't know what happened here. We just know C comes out. So it could either be U and C, V and C, or W and C. So we have to consider all those probabilities. So V and C is 0.6 times 0.2. The probability of C is going to be the union of U and C, V and C, W and C. So that's 0.1 times 0.4, 0.6 times 0.2, 0.3 times 0.7, and we're going to add all those together. So the probability comes out to be 0.324. Okay, I hope that helps.